We're going to look at how do you solve absolute value equations. First thing to understand is that absolute value is a distance from 0. So if you have your number line here, and I pick the number 3, and I ask you how far away from 0 is 3, well, it's 3 units. So the absolute value of 3 would just be 3. Now when we go to the other side, and I pick negative 3, and if I were to ask you how far from 0 is negative 3, since we're just talking about a distance, we would say that it's 3 units away. So our absolute value of negative 3 is 3. When you are doing absolute values, because it is an indication of distance, there aren't negatives. So anytime I have the absolute value of a negative number, it's actually the positive. When I have the absolute value of a positive number, it's still the positive because it's a distance. If this were school, and somebody asked you how far you live away from school, and let's say you live down here, you live south of school. If you live 5 miles, are you going to tell somebody that you live negative 5 miles away because you have to go south? Well, probably not. You're going to just tell them you live 5 miles because it's a distance. So it doesn't matter what direction we're going, whether it's positive or negative. When you're talking about distance, we always talk in terms of positives. So here's our first set of problems. This first one, the absolute value of x is equal to 7. These bars here, the straight up and down bars, mean absolute value. What you have to ask yourself is, okay, what values could I put in here for x that would give me a 7? So I'm looking for any numbers that are 7 units away from 0. Well, the first one would be obviously 7, so x equals 7. What you have to realize is that if I go to the left of 0, 7 units, that takes me down here to negative 7. So negative 7 could also be a solution. If I were to put 7 in here for my x, the absolute value of 7 is 7. If I were to put negative 7 in here, well, the absolute value of negative 7 is also 7. We have 2 different answers for this one. Now jump over here. Absolute value of x is equal to 22. You want to ask yourself which numbers are 22 units away from our 0. Well, we have a positive 22 again. But now remember, if you go to the left side for 22 units, we get a negative 22. So the absolute value of 22 is 22, and the absolute value of negative 22 is also 22, because it's a distance. Those are the 2 easiest kinds that you'll come up with. Now notice that we had 2 answers for each one of these. We had x equals 7 and x equals negative 7. X equals 22 and x equals negative 22. So what we're looking at here is this question mark. I don't know what it's going to be yet. Whatever is inside here has to be equal to 10, and what is ever inside the question mark has to be equal to negative 10, just like it was up here. We had an x equals 22 and an x equals negative 22. What's going to be different about this one is, what if I tell you the question mark, instead of just being an x, it's x plus 5. So what I would need to do is come down here to my question mark, and instead of this question mark, I'm going to put in x plus 5 and x plus 5, because whatever I put inside here I know can be equal to 10 or negative 10. Well, now I've decided to put that x plus 5 in there, so x plus 5 has to be equal to 10, or x plus 5 has to be equal to negative 10. You have 2 linear equations to solve. This top one, to get rid of the plus 5, we subtract 5 from both sides, so we end up with x equals 5. On the bottom one, to get rid of the plus 5, we subtract 5, so we get x is equal to negative 15. Now if I go back to check my answer, I had the absolute value of x plus 5 is equal to 10. Well, when I put 5 in here, you have to ask yourself, is that true? Well, absolute value signs are kind of like grouping symbols, so I have to do everything inside here first. So 5 plus 5 is 10, and then I have to ask myself, is the absolute value of 10 equal to 10? And that is yes, so I know the value of 5 works. Now this negative 15, when I plug that in there, I want to check again. So I've got my grouping symbols, so I need to do the addition here first. Negative 15 plus 5 is negative 10. And I have to ask myself, is the absolute value of negative 10 equal to 10? And that one works also. So notice again, I got two answers, except for this time they weren't opposites of each other because my equation was more than just an x. So one thing you're going to remember for absolute values is you're almost always going to have two answers. The only time you won't is if we're dealing with 0 over here. Okay, here's two more problems. We're going to treat them very similar to this middle problem. I am going to take that 2x minus 5 and I'm going to set up two separate equations. I'm going to set it equal to 13, and then I know that inside can also be equal to negative 13. And I'm going to solve my equation separately. So on the left side here I have to add 5 to both sides, and then I need to divide by 2, so I get x equals 9 for one of my answers. On the right side I need to add 5 and then divide by 2, and there I've got my two answers. So it could be 9 or it could be negative 4. Okay, the last one. This one's a little bit different because of this 2 out in front. Now I told you before that absolute value symbols are kind of like grouping symbols, so we don't want to start working on the inside of them until everything is gone around them. So this one, before I set up my equations, I need to divide both sides of my equation by 2. So now I'm just left with the absolute value of 5x plus 8 is equal to 13. Now that I'm down to just my absolute value symbols, now I can set up my two separate equations. I'm going to have 5x plus 8 equals 13, and I'm also going to have 5x plus 8 is equal to negative 13. Now I can do algebra to solve them. On the left side, subtract 8, divide by 5, and on the right side, start with the same thing, subtract 8, and divide by 5. This one doesn't divide out nicely, so I'm just going to leave it as negative 21 over 5. Okay, here is the second set of practice problems. Go ahead, pause the video, and see what you come up with for these. Remember, you're always going to have two answers unless you have it set equal to 0, which we don't in either of these cases. So go ahead, pause the video, and see what you come up with. Okay, on this first one, I started by setting up my two separate equations, 4x minus 8 equals 22, and 4x minus 8 equals negative 22. Went through the algebra steps, and got my fraction to reduce all the way down to 15 over 2. On this one, went through my algebra steps, and got my fraction to reduce all the way down to negative 7 over 2. This right equation, the first thing I had to do was get rid of this 5 on the outside because it was not part of my absolute value. So I divided that off on both sides and ended up with this new equation here in red. Then I was able to set up my two separate equations, the 4x minus 7 equals 6 and the 4x minus 7 equals negative 6. Went through my algebra steps and got 13 over 4 and 1/4. So make sure when you're doing your absolute value problems that you always get the absolute value isolated first. So in this case we had to get rid of the 5 on the outside. And then once you have the absolute value isolated, you set up two linear equations. One set equal to the number, and then one set equal to the opposite of that number. You will follow that process every time you do absolute value equations.